Welcome to ClickMyProject.com. Let me discuss about the process partition optimization in LDPC-coded OFDM system with PTS PAPR reduction. Let me discuss about the abstract of the project. This project proposes dynamic multi-frame processing schedule. This schedule efficiently utilizes the layered LDPC decoding with minimum pipeline stages, and this project presents architecture of block-level parallel layered decoder for irregular LDPC code. This code can be reconfigured to support various block lengths and code rates. In Wi-Fi wireless communication standard, the system presents an efficient comparison techniques for both column and row layered schedule and rejection based high speed circuits to compute the two minimum values from multiple inputs required for row layered processing of hardware friendly min-sum decoding algorithm. This system utilizes three pipeline stages. To evaluate this scheme, the system showed that the result is as good spread with lower area as compared to state-of-the-art circuits in this project. The system proposes an efficient comparison technique to be used in the construction of high-speed circuits for extracting the minimum values with a smaller number of pipeline stages. This resulted in lower latency and good frequency scaling. A dynamic multiple frame processing for LDPC decoding algorithm is used to remove the pipeline bubbles and minimize the memory overheads. The BR performance analysis of this decode for various code rates has been performed in additive white Gaussian noise channel environment. The peak to average power ratio of a transmitted signal is one of the main challenges in wideband multi-carrier systems that use orthogonal frequency division multiplexing or multiple input multiple output OFDM. Understanding the effects of PAPR on OFDM and MIMO OFDM system is critical when determining what techniques to use improve system performance. For the purposes of this blog post, we can use the terms OFDM and MIMO OFDM interchangeably without affecting the meaning of PAPR. Let me discuss about the flow diagram for our process. A low density parity check code is a linear error correcting code. It is LDPC encoder. A method of transmitting a message over a noisy transmission channel. An LDPC is constructed using a sparse byte parity graph. LDPC codes are capacity approaching codes, which means that practical construction exists that allow the noise threshold to be set very close for a symmetric memoryless channel. The noise threshold defines an upper bound for channel noise, up to which the probability of lost information can be made as small as desired. Using iterative belief propagation techniques, LDPC codes can be decoded in time linear to their block length. LDPC codes are finding increasing use in application requiring reliable and highly efficient information transfer over bandwidth or return channel constraint links in the presence of corrupting noise. Implementation of LDPC codes has lagged behind that the other codes, notably turbo codes. LDPC codes functionally are defined by a sparse parity check matrix. Next, the partition optimization. A greedy algorithm is an algorithm that follows the problem solving heuristic of making the locally optimal choice at each stage with the hope of finding a global optimum. In many problems, a greedy strategy does not in general produce an optimal solution, but nonetheless a greedy heuristic may yield locally optimal solutions that approximate a global optimal solution in a reasonable time. In general, greedy algorithms have 5 components: a candidate set from which solution is created. Next, the bit flipping. The bit flipping algorithm starts out the sequences. Each check node introduces a constraint. As in the previous lecture, each step the algorithm tries to find a bit flipping of which reduce the number of unsatisfied classes. The algorithm stops when for every bit the number of unsatisfied constraints is less equal to the number of satisfied constraints. Finally, performance has been analyzed. The number of bit errors is the number of received bits of a data stream over a communication channel that have been altered due to noise, inference, distortion, or bit synchronization error. Bit error rate is the number of bits per unit time. Bit error ratio is the number of bit errors divided by the total number of transferred bits. Let me discuss about the running procedure for our process. Select the main.m file, the current file, like the file, and run for executing this process. Here, LDPC encoding process are executed. In this algorithm, we perform partition optimization using greedy approach. After performing greedy approach, we implemented the bit flipping algorithm based on the greedy algorithm result. Here, initially the LDPC matrix is created. After creating the LDPC matrix, we implemented the partition optimization using greedy algorithm. Here OFDM process are implemented. After performing various iteration, we perform the receiver process and also performance analysis graph for our result. This is the information sequence, input information sequence, and this is the encoded bits, and this is the modulated message, and this is the IFFT in the transmitter side performing inverse Fourier first transform for compressing the signal, and this is the OFDM message, that is in this channel there will be a signal that will be passed to the receiver side. So this is the receiver part. This is the FFT message after performing the first Fourier transform result, and this is the demodulated result, modulated of our message, and this is the frame error rate graph for various EB number, and this is the resultant values, and this is the frame error rate graph for various EB number, and we varies the GPU values, and also this is the error rate graph by varying the EB number from 0.0 to 2.52 and again 2.5 to 5. Finally, we analyze the LDPC perform encoding algorithm with partition optimization.